Welcome to Knowledge Base. Let us solve this problem quickly. A step-up transformer increases the voltage from 120 volts to 240 volts. If the current in the primary coil is 5 ampere, calculate the current in the secondary coil, assuming the transformer is 95% efficient. We are going to sort out the parameters quickly. It is a step-up transformer, so the primary side has the lower voltage. So the V primary is 120 volts. The secondary is 240 volts. Vs is 240 volts. At the primary, the current is 5 ampere. So IP, primary current, is 5 ampere. We are calculating the secondary current Is, so we don't know it, question mark. Given that the transformer has an efficiency of 95%. Now that we know the efficiency, it is very easy to solve this problem. First, what is the formula for efficiency of a transformer? For a transformer, the efficiency is given as the output power divided by the input power times 100. Looking at this question, you won't find the power given. However, we know that the power in electric power is given as the product of the current and the voltage. The output is the secondary side of the transformer, while the input is the primary side of the transformer. If power is voltage times current, it means the power output will be the product of the secondary voltage and the secondary current. The input power will be the product of the primary voltage and the primary current. So we have that the efficiency will be Vs times Is divided by Vp times Ip times 100. We are looking for Is, so we can make it subject of the formula. If we make Is subject of the formula, we are going to have that the secondary current Is will be equal to the efficiency times the primary voltage times the primary current divided by the secondary voltage times 100. To make Is subject to the formula, you cross multiply Vs Is times 100 will be on one side, efficiency times Vp times Ip will be on the other side, so that the product of this will be divided by Vs times 100 to obtain Is. This is mathematics. Physics uses mathematics to solve its problem, but it is not actually concerned about how you solve the mathematics. In other words, it does not look at the mathematical step because it is not a test of mathematics actually. So if you skip steps and are able to do something like this, you are absolutely fine as far as physics is concerned. So Is is this, and we cannot put in values. Efficiency is 95, so we put in 95. Vp is 120, Ip is 5, Vs is 240, and then we have 100 as a constant for efficiency, right? So Is will simply be 95 times 120 times 5, that gives us 57,000. 240 times 100 gives us 24,000. The division here simply gives us a secondary current of 2.375 ampere. And this is the answer to the question, and it is very, very simple. Here is another simple exercise for you to do. If this transformer in question was 100% efficient, what would be the current in the secondary coil? So calculate the secondary current assuming the transformer was 100% efficient. Please put your answer in the comment section and hope to see you in our next video.